Hey everybody, today we're going to talk about rational functions and specifically equations of asymptotes found in rational functions. And you might have a couple questions. First of all, what is a rational function? A rational function is any function where f of x equals a ratio or a fraction. That is a rational function. The parent function is what we have here in number 1, f of x equals 1 over x, and that looks roughly like this. So that's what the graph of a rational function looks like. Okay, so next question, what is an asymptote? Because what we're talking about is determining equations of asymptotes. So what is an asymptote? An asymptote is a line that a graph of a function will get infinitely close to, but will never touch. Right here, there's a vertical line that this on the top end, over here on the right, it's going to approach, the graph is going to approach that y-axis, and on the bottom, from the left side, it's going to also approach the y-axis, but it'll never touch it. It will get infinitely close, but never touch it. That is a vertical asymptote. And here's a horizontal asymptote. On its end behavior, on the right, it'll get infinitely close, but never touch the x-axis. And on the left side, same thing. It'll get infinitely close, but never touch it. So in number 1, f of x equals 1 over x. There's a picture of it over on the right. It's got two asymptotes. The first one is the vertical asymptote. And that's the y-axis, or x equals 0. That's an asymptote because the graph can never touch that. Well, why can't the graph ever touch that? Because if I put in a 0 for x, I'll have 1 over 0, and we cannot divide by 0. So x cannot equal 0, therefore this graph will never touch the value x equals 0. So it's got a vertical asymptote at x equals 0. We can see from the picture it's also got a horizontal asymptote, and that is at y equals 0. Well, how can I tell just by looking at the equation that it's going to be y equals 0? So here's what you can do to determine a horizontal asymptote. The denominator has a degree of 1, and the degree just means the highest exponent of the variable is 1. If there was a squared here, then the degree would be 2. The highest variable you find on an exponent is the degree. In the numerator, there is no x. So what we're going to do is we're going to add 0 x's. And now we've actually made the degrees match in the numerator and denominator. Adding 0x did not change any value. So it's okay just to add a 0x. In the denominator, I have 1x. If I divide those coefficients, 0 divided by 1, I get 0. So that gives me my horizontal asymptote. So in number 2, I can find the vertical asymptote by setting the denominator equal to 0. The denominator cannot equal 0, so x cannot equal -3, which means for this equation, the graph is going to be shifted 3 to the left, so this vertical line right here would actually be at -3. So the vertical asymptote is at x equals -3. The horizontal asymptote I have a first degree in the denominator, so it's x to the first power. I have no x's in the numerator, so I can add 0x. And in the denominator, I have 1x. 0 divided by 1 is 0. So I've got a horizontal asymptote at y equals 0. In number 3, I'm going to find my horizontal asymptote by setting the denominator equal to 0. So x squared minus 1 cannot equal 0, which means x squared cannot equal 1. When I take a square root, I automatically have two solutions, plus or minus. So x cannot equal plus or minus the square root of 1. So I've got a vertical asymptote at x equals the square root of 1, the positive square root of 1, which is 1. And I've also got a vertical asymptote at x equals the opposite of the square root of 1, which is negative 1. So this one is actually going to have two vertical asymptotes. So if you graph this, you should see two vertical lines that are not touched. Then, for the horizontal asymptote, the denominator has a degree of 2, the numerator has a degree of 1, so I need to add 0x squared to the numerator, and I've got 1x squared in the denominator. 0 over 1 is 0, so y equals 0 is my horizontal asymptote. In number 4, once again, we'll set the denominator equal to 0. Say that it cannot actually equal 0. This one could be solved by factoring. So we need numbers that multiply to make negative 10 and add up to negative 3. And numbers that do that are 5 and negative 2, or negative 5 and 2. Negative 5 times 2 is negative 10. Negative 5 plus 2 is negative 3. So it factors to x minus 5 times x plus 2. And my two solutions then are going to be the numbers that make each factor a 0. So the number that makes this factor a 0 would be 5. 5 minus 5 is 0. So x cannot equal 5. And the number that makes this factor 0 is a negative 2. Negative 2 plus 0, or plus 2 is 0. So x cannot equal 5 or negative 2, which means there's a vertical asymptote. There are two of them, one at 5 and one at x equals negative 2. And the horizontal asymptote, the denominator has a degree of 2, the numerator has a degree of 1, so I'm going to add 0x squared, and I've got 1x squared on the denominator. 0 divided by 1 is 0. There's a horizontal asymptote at y equals 0. Number 5, once again, set the denominator equal to 0. X minus 3 cannot equal 0, so x cannot equal 3, which means I've got a vertical asymptote at x equals 3. And for the horizontal asymptote, I actually have the degrees matching this time. First power, so I've got 7 x's, and in the denominator 1. 7 over 1 is 7. So this time I have a horizontal asymptote at y equals 7. So this time the horizontal asymptote is shifted up 7. Number 6, 2x plus 6 cannot equal 0. So 2x cannot equal negative 6. So x cannot equal negative 3, so I have a vertical asymptote at x equals negative 3. And again, the degrees match, first power and first power. 5 over 2, my horizontal asymptote, is y equals 5 halves. number 7. 3x squared minus 12 cannot equal 0. So 3x squared cannot equal 12. Divide by 3, x squared cannot equal 4. And then take the square root, and there's going to be a plus or minus. X cannot equal plus or minus the square root of 4. So my vertical asymptote, I have 2 of them. One at x equals the positive square root of 4, which is 2, and one at x equals the opposite of the square root of 4, which is x equals negative 2. The horizontal asymptote, my degrees match. The numerator and denominator both have a degree of 2. 15 over 3 is 5, so at y equals 5, there is a horizontal asymptote. In number 8, we'll start actually with the horizontal asymptote. In number 8, this is the first time we've got a degree in the numerator that's higher than the one in the denominator. So we have to actually add a 0x squared to the denominator. And I've got 1x squared in the numerator. That gives me 1 over 0, which is undefined. So there actually isn't a horizontal asymptote in number 8, and in the next video we'll deal with what kind of asymptotes actually exist in numbers 8 and 9.